Hello everyone, welcome back. Today we are going to learn real numbers chapter, example 1. Now let's read the question. Use Euclid's algorithm to find the HCF of 4052 and 12576. Now here let's begin our solution. Now here we will find this question by using Euclid's algorithm. As it is given in question, we should use Euclid's algorithm. So Euclid's algorithm is A is equal to BQ plus R. Now here we have to see that 4052 is smaller than 12576. Now here in A is equal to BQ plus R, A is divided, B is divisor, Q is quotient and R is remainder. So I'll write it that side. I'll write 4052 here and 12576 in the dividend place. Now I'll divide 4052 by 3. I'll multiply 4052 into 3. The answer is 12,156. Now here we'll get the remainder 420. Now I'll write down 12,576 as 4052 into 3 plus 4020. Now this divisor will come here, 4052. Now here 420, I'll multiply it by 9. So we'll get the answer 3780. Now if we subtract this, we'll get the answer 272. So now I'll write 4052 as 420 into 9 plus 272. Now this question's divisor here. Now we have to divide 272 by 420. I'll divide it by 1, that is 272. If we subtract these numbers, I'll get 148. So I can write 420 as 420 and 272 will get the answer 148. So we can write 420 as 272 into 1 plus 148. So this 272 will come here. Now here I'll multiply it with 1 and I'll get 148 here, and if we subtract these numbers, we'll get 124. So we can write 272 as 148 into 1 plus 124. Now I'll bring previous question here. So 148. So here 1 and 124. So if we subtract 148 and 124, we'll get the answer 24. So we can write 148 as 124 into 1 plus 24. Now 124 will come here. And 124 5s are is 120. So 4 will be the remainder. So 124 can be written as 24 into 5 plus 4. Now 24 will come here. Now 4 6 is 24. So 6 and 24 here. Now here is 0. Okay. So here 24 can be written as 4 into 6 plus 0. So we'll get the remainder here 0. Then if we get the remainder 0, then that means that it was the last step. So we have first, second, third, fourth and fifth, sixth, seventh. We have 7 steps here. Now here the divisor will be our HCF. So HCF of 4052 and 12,576 is 4. This question is completed. Next we'll see the example 2. Let's read the question. Show that every positive integer is of the form 2q and that every positive odd integer is of form 2q plus 1 where q is some integer. Now let's take a as any positive integer and b is equal to 2. Now we'll solve this sum by using Euclid's division, which is a is equal to bq plus r. Now where r is equal to 0, r is greater than 0 but it should be less than b. So we have here b 2. So less than b is the possible values of r is 0 and 1 because b is r2 and we'll get 0 and 1 less than 2. So where r is equal to 0. First we'll take r is equal to 0. Now a is equal to 2q plus 0. That is equal to a is equal to 2q. Now here if let it be any number. For example, now q I'll take it as 1. 2 ones are is 1. If we take here 4 or 7, we'll take 7. 7 twos are 14, which is an even. So this sum is an even. And here we'll take 2q plus 1 where r is equal to 1. So 2q plus 1, a is equal to 2q. Now here this is an odd. I can say this is a odd because if I take 7 here, 7 twos are is 14. 14 plus 1 is 15. In any number, if we multiply with any number, that is q, and if we add, we get an odd number. So this is an odd. So we can conclude that every positive odd integer is of form 2q plus 1. This is the question. Hello everyone, welcome back. Today we are going to learn example 3. Now let's read the question. Show that any positive odd integer is of form 4q plus 1 or 4q plus 3 where q is some integer. So now let's begin our solution. We will take a as any positive integer and b is equal to 4. Now this is solved by Euclid's division. So Euclid's division is nothing but a is equal to bq plus r, where r is equal to 0, more than 0 but less than b. So here b is 4. So less than b is, so the possible values of r is equal to 0, 1, 2, 3. Now these numbers are less than b. So this can be the possible values of r. First we will take where r is equal to 0. So we will take a is equal to 4 cube plus 0, where a is equal to 4 cube. Now if we take 4 into 2 is 8. 8 is an even number. So any number which we multiply by 4 is even. So this will be also even. Now we will take r is equal to 1. So a is equal to 4 cube plus 1. Here, if we multiply q with any number, we'll get even. But when we add plus 1, we'll get odd number. So for example, 4 2s is 8. 8 plus 1 is 9, which is an odd. So this will also be an odd. So next we'll take r is equal to 2. A is equal to 4 cube plus 2. Now this will be even because 4 2s is 8. 8 plus 2 is 10. 10 is a even number. So 4 cube plus 2 is even. Now we'll do 3, where r is equal to 3. A is equal to 4 cube plus 3. Now 4 cube will get even plus 3. Right? 4 2s is 8. 8 plus 3 is 11, which is an odd number. So 4 cube plus 3 is an odd number. Hence, we can conclude that any positive integer in the form of 4 cube plus 1 and 4 cube plus 3. We had to find this and we have proved this, hence this question is over. Now this is example 4. Now let's read the question. A sweet seller has 420 kaju barfis and 130 badam barfis. She wants to stake them in such a way that each stake has the same number and they take up the least area of the tray. What is the number of that can be placed in each stake for this purpose? Now let's see the solution. So we have taken here maximum numbers of barfis can be placed here is equal to the HCF of 420 and 130. Here 130 is less than 420. So we will do this by Euclid's division, which is a is equal to bq plus r. Now here a is dividend, b is divisor, q is quotient and r is remainder. So I told you before 130 is less than 420. So I'll take 420 here, 130. Now let's divide it. So 130 3s is 390. And if we subtract these both, we get the answer 30. So here we'll write it down. 420 is equal to 130 into 2 plus 30. So previous question's divisor will come here. So 34, and now here 420 can be written as 130 into 3 plus 30. Now previous question divisor will come here. Now this will come. So 34 is 120, and if we subtract this we get the remainder 10. Now 130 can be written as 30 into 4 plus 10. So previous question's divisor will come here, and 10 3s is 30, and we get the 0 here. So 30 is equal to 10 into 3 plus 0. Now we have first, second and third step, and the last step is this, and the last step's divisor is 10, hence the HCF is 10. So the stack required can be placed is 10. This question is completed. Hello everyone, welcome back. Today we are going to learn example 5, real numbers. Now let's read the question. Consider the number 4n where n is a natural number. Check whether there is any value of n for which 4n ends with digit 0. Now for this solution they have said that it should end with 0. Now first we'll see 5 2s is 10, which ends with the 0, and if we have two pair of this, it ends with the 2 0. Now let's see if we have 5 and 2 pair, then then 4n ends with 0. If not, it does not end. So 4n is equal to 2 into 2 the whole n. Now here you can see only 2 is there, but 5 is missing. So we can say that it does not have pair of 5 and 2. So in its prime factors. So we can conclude that it does not end with any 0. So we can write that where n is a natural number and if it should end with 0, then it should have the pair 5 and 2. Then this 4n does not end with any 0. This question is completed. So please, if you like this video, please subscribe our channel.